Today I would like to talk about equations, simple linear equations. So let's first think about what they are. Let's start with an example. Let's say I have something like this, which says 5x equals 10. So what we have here is something we denote it as x, and that something is unknown. Okay, it's something we need to find. So what's written here is that we're looking for a number which we call x, and if you multiply that number by 5, you should get 10. And the question obviously is, what is x? And obvious answer is x equals to 2, because if you take 5 multiplied by 2, you get 10. Now this is probably one of the simplest equations you can have. Let's just make it a little bit more complicated. Let's write equation like this. Here we have 6x minus 3 equals 21. What it means is we're looking for a number which we call x. And if you take this number, you multiply by 6, and then you subtract 3, you're going to get 21. Well, if you think a little bit, you'll figure out that in this case, x needs to be 4. Because 6 times 4 minus 3 is 21. Now what you saw so far are simplest probably examples of equations. So what are characteristics of the equations? There's an unknown number, which we call in this case x, but we could have used any other letter of the English alphabet, Greek alphabet, any other alphabet you can think about, or it could be actually any symbol you wanted to use, whatever you want. So, and also what you have besides those unknowns, you have equality sign, right? And that's why what you see here is called equation. We equate what was on the left should be equal to what's on the right. So, so far, when we look at our equations, we see that there's only one term with unknown x. But in reality, number of terms is not limited. We can have several terms that consist of our variable x. So one of the examples is like this: 7x minus 3 equals 3x plus 9. Now what we have two terms that contain x, 7x and 3x. And what we're saying here is that because of the equality, the left-hand side should be equal to the right-hand side. And what we would like to find x that will satisfy this, that will make left side equal to the right side. And if you think a little bit about it, we find that x should be 3. Why is that? Because if you look at the left-hand side, if we take 7 times 3 and subtract 3, we get 18. If you look at the right-hand side, 3 times x is 3, plus 9, we also get 18. So left-hand side equal to the right-hand side when x equals to 3. So those were kind of a simple examples, and you can say, well, the way to solve these equations is just to guess. How many times do we need to guess? Well, so far we got numbers like 2, 3, 4, all simple whole numbers. We can always do that. But sometimes things get more complicated, because x doesn't have to be a whole number. It could be any number you want. So let's look at the equation 5x plus 2 equals 3x plus 7. Well, again, if I find my x, if I take my x, multiply by 5, and add 2, I should get the same number as if I take my x, multiply by 3, and add 7. So what x would satisfy this condition? Well, if you try to look for an answer among whole numbers, you'll get disappointed because none of whole numbers satisfy this condition. In fact, the x that satisfies this condition is a 5/2. Or if you prefer decimal fractions, you can write it as 2.5, 2.5. So in general, we have to have a procedure that will help us solve all kind of problems like this, because just guessing is not always an option. So let's start talking about procedures in the next video. See you then.